purpose of this experiment or test is to show how far up that hill I can move water from this rain catchment. So what we have going on here is what's called a water level, and this allows us to determine a certain point on the landscape over very long distances. Because water is self-leveling in a container, it's not in a container like it's dumped on a hillside. It will go to the lowest point, as many people know. But if it is contained, it will self-level. So what I'm demonstrating here is the leveling. So I'm adding this so that it goes higher, and we have a better reference point down at the rain gutter. So in a second here we'll go look at the rain gutter. That tells me that this point is higher than the rain gutter right now. You'll see here it'll kind of self-level. It'll kind of go and then it'll come back up. So here it goes, and now it's actually balancing itself out, and that may take a little bit. You don't want to start measuring off of that point. So we'll give it a second here, and now let's go check on the other end and see where the water level is over there. Okay, so now we're back at the other location, and we're actually, I'm standing downhill. I'm probably about 10 feet lower than I am over there, but this will actually tell us if that is the case and what the measurement is. So you saw uphill on the ladder over by the barn the level of the water. So what I'm going to do, you can see here, this is the level. So I installed these rain gutters a couple days ago and just completed it yesterday, and then I put in this downspout this morning. So what I'm going to do is I'm going to measure the difference. This is about the base of the gutter system, and that's about a foot above the water line. So we'll keep that in mind. So now we're back uphill. Now we're back by the ladder. And this is about 120 feet away. So we'll take that same measurement. The whole point of this is that point right there is the same point. If I had like a level, like a level that a carpenter would use, like you see them in like a 4-foot or 6-foot level, a real long level. If I had that level and I had one that was 120 feet, this point and that point that I showed you down by the shop there, that would be the same point. That's a level line. So if I go 1 foot up from that, which would be right here, if I have a Sharpie in my pocket, I'll actually make the mark on the ladder so it's easier to see. There's that line right there. So that line right there is the bottom of the gutter system. We measured off a reference point. So what that means is I can take water up to this point, anywhere up on this hill. In just a second, the next shot will give you is an idea of how far away we are and how much higher we are than that other point. And the point of that is that on our homestead, on this property, what we want to do is we want to store water at the highest point. So if we can collect water high off the rooftop, we put it in a pipe system, and I'm going to show you one that we rigged up this morning. And the kids kind of started asking, hey, how is that possible? How is the water able to go up the pipe and into a bucket that's 5 feet off the ground? So this is the same point. So eventually what I'm showing you, here's the application. I can bring a tank over to this point. I can set it right on the ground. I don't have to dig a hole or anything like that. And I can run a pipe up or a tube uphill, and I can run it so long as the top of that tank is below this line. And that, let me come over here for a second. So that tank would be here, and then that water, as long as it's below this line, that water will feed this tank. And then in just a second, like I said, the next shot we're going to show you is over the landscape, and this is actually the highest point of the property. So then from here, if the water is stored here, I can pipe water downhill anywhere on the property. I can go in any direction, and it will all be gravity fed. I just run the pipe downhill. You know what happens if water is on a hill? It just runs downhill. So then there would be a valve at the bottom of the tank, lower, and that will allow that water to go out and be used downhill. So now we'll show you what it looks like from a vantage point of where these tanks would be, looking downhill. All right, so here we are, and now you're looking in the opposite direction. You're looking east right now. Before you were looking west. So now you're looking downhill, and you can actually probably see a pond over down there. But if the water tanks were up here and stored here, then we can gravity feed all that water back down just by opening a valve. We don't have to run a motor. We don't have to have anything mechanical. It's very simple. All you have to do is open a valve. So that is the essence of a water level and how it works, and it shows where you can place things. We'll also be using this in the future, and I'll show you how to find what they call key lines or lines on a contour. So if you have a hill, you can find points on that hill using a water level, and you can determine where, if any, you want to do earthworks to create mounds and store water on the side of the hill. We have a lot of hills here, so one of the major challenges, it actually works to our advantage, but one of the major things that we have to learn, because we don't have a lot of experience working on these type of contours, is how to work with the hills and use them to our advantage. So let me add one more thing to this. So the another thing that you can do is you can tell how far you're gaining in height or ground level. So what we can do is we can go to that reference point, which is right here, and from the ground to the reference point is 51 inches. So what we do is we go back downhill, we measure that, and then we subtract. So remember that 51 inches, or actually it's closer to 52 once I push it down into the grass. So 52 inches. All right, so let's go back downhill. All right, okay. So now we're back downhill. Just one little note when you're doing this, if you're running hose or pipe or whatever it may be, and you're taking measurements off the reference, you want to make sure that you don't move that hose around at all. Because if you move it, it's going to change your reference point a little bit. Because you could have moved the pipe uphill, which is going to make the water rise a little bit. So if you don't want any false readings, once you've made one measurement, don't move your hose or your pipe, whatever it may be. Okay, so now we're going to go from ground level here, and it's much higher, as you can see, on a reference point, and now it's at 99 inches above the ground. So the difference would be 47 inches. So the ground level here is 47 inches lower than it is up there. So if you were to think about this, like, how could I possibly measure the height difference where I'm at to up on a hill somewhere, any given point on a hill? This is how you can do that. So as long as you have enough hose to go between those 2 points, what you do is you get the water to level, and then you measure the difference of that. So on the uphill side it was 52, and then on the downhill side it was 99. 99 take away 52 equals 47 is the difference in height here to there. So let me actually next show you an actual application. This is kind of what got the kids questioning me, and then I decided, okay, let me put together something and kind of explain this. Okay, so here we go. So we're collecting the water up here. You can see the water coming into the white PVC from the downspout. Inside of there it's kind of covered, but the water from that hole about 40 feet collects that whole half of the roof on the shed, and it goes into here. Now it runs along the ground here, and it comes this way, And it does go downhill a little bit. We're probably only dropping maybe 6 inches in elevation. It goes up against gravity 42 inches. And the reason it can do that is because this height is lower than the height where it enters the pipe. So if that were, for example, 100, we know that it's greater than 99 inches because we just measured it. We'll say it's 110 inches, okay? We could actually do the same thing, and we could go up, right here we're at 42, we could go up to 110 inches, and that water would level. That water would level out. This is the same application, and this is kind of what I was explaining before, is you can actually take the water uphill to its storage point because the water will self-level. It kind of doesn't make sense when you just think about it and you say, there's no way water can travel uphill. Well, it's actually not going uphill. It's in a container, and that's the key. The pipe is the containment, and inside of a containment, water will self-level. So just as a grand view or a big picture view example is sea level. A lot of times you hear elevations, like that mountain is 7,000 feet above sea level. Well, that's how, and that's the reference point that many scientists use to measure elevation. It is because sea level is a constant reference point. All the way around the world, that water, believe it or not, is level. It is the same distance from the center of the earth outward. So then if you go and you measure beyond the sea level, no matter where it's at in the world, and you measure away from the center, which is the definition of up. Up is any direction away from the center of the earth. So if you measure up or away from the center and away from the level of seawater, that difference becomes your elevation. So sea level is 0, and then you could go, let's say, to the Dead Sea. Now the Dead Sea is below sea level. In order to go up, like say Mount Everest is, we'll say it's 10,000 feet. So you could actually measure from sea level at that point, and you could go up above that. There's your 10,000 feet. That's how they're getting that elevation. You could go all the way across the other side of the globe to North America to a mountain that I'm familiar with, Mount Lemmon, and that's somewhere, I'm not sure, I think it's like 7,000 feet. But they can have that reference point and use the same thing to measure elevation. So there's a little lesson in leveling and elevation and all kinds of goodies that I hope you can use. 47. So, yeah, that's right. 47. You have me second guessing my math.